Okay, so 26, finishing this up. We got to this point yesterday, and we have a dH/dt, we have an H, so those pieces should be fine. The dV/dt is going to be fine, but this B, we have to find something to plug into there. Where did this equation come from? Okay, I gotta think. Let's see. Okay, it was the volume, right, of this swimming pool. So this swimming pool is a trapezoid, and then to find the volume of something, you take like the area of the base times the height. So we think of this as like our base here, and then the height as like the width of the pool coming out at you. Okay, so that's why we multiplied it by 20. Does that make sense? And then this here is the area of the base, or the area of this trapezoid. Okay, and we know it doesn't actually get up to 34, so we can't use that number right now. So we're using B as one of our bases. 12 is the other base, because 12 is always going to be one of them. So you average your two sides, so that's the 12 plus B times a half. And then you multiply by the height of the trapezoid, which is just H. That makes sense? Okay, so area of a trapezoid, you average your bases, multiply by the height. Okay? Otherwise, I mean, you could split it up into a bunch of triangles and stuff, but then you have a bunch of variables going on in there. Any other questions before we try to get rid of B? Let's clean this up one more step before we try to, you know, get crazy with this. So the 1/2 and the 20, I can just switch to a 10. Good. I'm not going to do too much cleaning here before we plug in. Okay, so this is our rule. We're going to try to find something for B. This seems kind of counterproductive, but it's going to end up working out in the end, so just deal with it, I guess. So our B is equal to x plus 12 plus y. Do you see that? So I'm going to write that down first. We're not going to plug that in because that's just going to give us more of a mess. And we want this in terms of what? What variable do we want? H. So instead of having to try to get B in terms of H, do you see how we should be able to get X and Y in terms of H because of these triangles now? Okay. So with similar triangles, this here is, look at this triangle to start with, okay? So looking at that triangle, I know X is to H as what is to what? What's this length here? Nope. 6, isn't it 6? You see that? So X is to H as 6 is to 6, right? Isn't that 6? So we're using similar triangles. You use the big triangle here, which is 6 by 6, and the small triangle, which is X by H there. So you go X is to H as 6 is to 6. So what's X equal? Okay, let's cross multiply. So we get 6x equals 6h, so doesn't x just equal h? So then instead of x, I can just put h in that spot when I'm there. Try to set up a proportion for this triangle here. And solve for, like, get y in terms of h. Does someone have that similar triangle, or the similar triangles proportion set up? Yes? What'd you get? What? Y is to h as 16 is to 6. That looks good. Okay, so we went this side is to this side as the 16 is to 6. And then we would cross multiply. And then solve for y, so I would divide by the 6 there. So I get y is equal to 8/3 h. Does that look right? So then we can plug those into here. So I know my b is the same as, instead of x, I'm going to put h plus 12 plus, instead of y, I'm putting 8/3 h. And then you can combine like terms together and plug it into there. Can we finish it from there? Because once we plug it into here, then you take the derivative, you plug in your known values, right? I'm going to give you time to just finish this problem, but let me know if we get stuck anywhere else and we can tackle it together if we need to. Yep. I would probably multiply it out, I guess. I don't know. Let's see, I got 10. Inside here I got 24 plus 11/3 h times h. And, I mean, there's two ways you can do it. You can just leave it as, 10h out front and the 24 plus 11/3 h, and then treat it as like a product rule. Or you can multiply it through. I think multiplying through is probably going to be, I don't know, cleaner, I guess. And then from there, we just take our derivative. So derivative of v is going to be dv dt. The derivative of 240h is just 240, but then we need a dh dt whenever we take derivative. Pull the 2 down front. And then we have a dh dt in the back. And then you just go back to what you know. You know dv dt is 0.8, so 0.8 goes in here. We want to find dh dt, so I'm going to factor a dh dt out of this side, and then we know h is 5. And then you just divide by this piece, right? I think I did everything right there. When I got done with this, I guess if we left it as a fraction, I end up with like 3/2275, which is approximately 0.00132, which you'd only need it correct to 3 decimal places on the AP test, but that's what I would do. What would our label be if it's dh dt? What's h in? Feet. And our t is in minutes, so feet per minute. A lot of times that gets you a point there. That's why I'm stressing the labels. So setting up 38 here, we know that AP plus PB is going to be 39, which I'll probably use at some point here. Passes over the pulley P. The point Q is on the floor 12 feet directly beneath P, so this is 12. We got that in the picture. And between the carts, cart A is being pulled away from Q, so A is being pulled this direction at a speed of 2 feet per second. how fast is cart B moving towards Q? So if this one's going this way, this one's got to be going this way. So this is what we're trying to find here. At the instant when cart A is 5 feet from Q. So I'm going to call this length something, because that's definitely, you know, the piece that I'm given. So let's call this X. Does anyone want to use a different variable? Did the book use a different one? You want to use A? Let's use A. Okay, so if this is A, what is this 2 feet per second? dA dt. So this is my known. I also know this, which might help me at some point. And then I'm trying to find, so maybe we call this B. So we're trying to find how fast car B is moving towards Q. So I'm trying to find what? dB dt. When A is 5. It says when this length is 5 here. Okay. Just right off the bat, what I see is if this is, when this is 5, I know this is 5, this is 12. Could I find this length here? Yeah. And if I know this length here, couldn't I find this length here? Because they add up to 39. And then couldn't I find B? I'm guessing we're probably going to need B, so we could find that and plug that in. We'll do that in a second here. How can I relate these to each other? This is where I would go with it. I can't guarantee it's going to get us where we want to go, but that happens. So we'll just try it and see what happens. Okay, I would go, let's call this X and this Y. Okay, I'm feeling like, okay, instead of doing this, because that's just introducing too many variables, we're just going to go, we're still going to use Pythagorean theorem. So Pythagorean theorem here is going to give me a squared plus 12 squared, right? And so this length is the square root of that, isn't it? And this one over here would be what? The square root of b squared plus 12 squared. And what do these two add up to? 39. So that's what we're going to do here. The square root of this plus the square root of b squared plus 12 squared, you can write that as 144 if you want, is equal to 39. And now we take the derivative. So it is ugly. I was hoping that there would be a kind of cleaner way to go about it, but why does it work? What? I feel like it's good because we have dA dt here, and we're trying to find dB dt. So A and B are the two variables that are in here. Do you see that? And I know A, and I can find B, right? So it should work out. Now, it's going to be kind of ugly, but am I going to end up with anything except for numbers, dA dt, and dB dt, and A and B? No, right? So I should have everything that I need in this equation. The problem when I was thinking, oh, I'm going to put x here, is then you have another variable and you know nothing about that variable. Does that make sense? So that's why we're going to be using, you know, this piece here in order to just have those variables. So if I take the derivative of this, the outside function is the square root, so I'm going to have 1/2, and I leave the a squared plus 144 to the -1/2. And then the derivative of the inside function is 2a. And then I need what in the back? dA dt. Same thing for that one, so go ahead and do that other one. And I'll clean this up here. I would just write it like this. The other one ends up being what? Isn't it pretty much the same? So instead of a, I have b over square root of b squared plus 144. And then in the back, db dt. And it equals what? 0, because the derivative of 39 would be 0. So it looks like I am going to have to find b, so go ahead and find b. Okay, if this is 5 and this is 12, this is going to be what? Right here, 13. And if this is 13 and this full length is 39, what's this going to be here? 26. And if this is 26 and this is 12, what's this going to be here? I'm not doing it in my head. People are telling me answers. What did you say, square root of 500? Okay, let's leave it exact. So square root of what? I can't hear people. Okay, we're getting different answers. It should be minus, right? 26 squared minus 12 squared. Punch that in quick. 532? Okay. And I'm just gonna, I just can't hear you. I really do think I have a hearing problem, and I'm not joking, okay? I really can't hear people. I don't really want to go get a hearing aid, though. I'm not old enough yet. So we got 532 here. So then we can plug these three pieces in, can't we, and solve for dB dt? So go ahead and plug them in. Just make sure your answer is correct to 3 decimal places when you're done, so you guys remember how to store numbers in your calculator. If you need to do that, okay? But go ahead and plug them in. I'll look up what the answer is supposed to be here so you can compare it, and you won't have to look it up then. And theirs is not correct to 3 decimal places. The book only does it to 2 sometimes for whatever reason, but this will give you a good idea. All right. So we get an answer that's negative here, but then it says how fast is car B moving toward Q? So it's moving toward Q at this rate. So your actual answer isn't negative, but dB dt is negative. So. Okay, the other one we're going to look at here is number 46. 46 is talking about a clock, so I believe, yeah. So I'm just going to start with a good old picture of a clock here. So it says the minute hand is 8 millimeters long and the hour hand is 4. How fast is the distance between the tips of the hands changing at 1 o'clock? So I'm going to set my clock at 1 o'clock. So at 1 o'clock, the minute hand's up here, and the hour hand is, you know, here-ish, and it's about half the length. So what I know is I know this was 4, I believe, and this was 8. And what are we trying to find here? Am I trying to find how fast the angle's changing? What does it say? The distance between the tips. So we're trying to find how fast this here is changing. So you're going to call that something, and that's what we're trying to find. So what would I write for what we're trying to find here? Dx dt. Okay, and when it's 1 o'clock, what else am I going to need in this picture in order to do something? I can't really do anything with that, can I? Is it a right triangle? No, so I can't really do anything there. So Mackenzie was kind of on the right track with, this angle. We need that angle there. At 1 o'clock, do I know what that angle is? I should, right? If you think of a clock, it's 1/12 of the full circle, so it's 1/12 of how many degrees? 360. So if you want to do it in degrees, that's fine, but then we need to switch it to radians, right? So we'd have 360 over 12, which gives me 30. A lot of calculators going on. And then to switch from degrees to radians, what do I multiply by?
1 pi over 180.
Very good, pi over 180. So this turns into pi over 6. I almost wrote 60. So we're trying to find dx dt when theta is equal to pi over 6. Any questions on where I came up with any of that stuff? Okay. Okay. The minute hand goes around every 60 minutes. So could I find the rate of the minute hand that's moving? Yeah, I guess. I don't know what he's saying. Okay, so let's see here. The minute hand goes around once an hour, which would be, let's say, 2 pi radians per hour. Let's just leave it like that, okay? Let's just do it per hour. Because the hour hand moves around once every... The hour hand makes it all the way around every how many hours? 12 hours. So it goes around 2 pi every 12 hours, right? So this would be radians per hour here. So what's that going to reduce to?
Pi over 6.
Pi over 6 radians per hour. Okay, so this one here is the minute hand. This one here is the hour hand. Does that kind of make sense? Okay. Okay, so the angle theta between them is changing at a rate of d theta dt equals, we would take the pi over 6 minus the 2 pi. Or if you did it the other way, it would just be positive instead of negative. So that's going to be negative 11 pi over 6 radians per hour. So this is a piece of what is known here. So I'm just going to throw that up in here. And if you had it positive, again, really not a big deal. If they're both moving to find how fast that angle is changing, it's going to be the difference between how fast those two pieces that create the angle are moving. I don't know. It's just a fact. It just is, yeah. If you don't understand this one, it's okay. You might not get all the bonus points on the quiz because I might throw a really hard one on there just for fun, okay? But I will also have an easier one on there where if you know how to do the easier ones, you'll be fine. Okay, they're bonus points for a reason. You gotta, if you know the harder one, you're gonna obviously get more bonus points. If you know the easier one, you're gonna get those, so. I'm not gonna put this one on there. Does that make you feel better? Okay. Okay, how can I relate theta and x to each other? I think I already told you. I can't use SOHCAHTOA because it's not a right triangle, so I have to use law of cosines. Yeah, that. Okay, so law of cosines. This is the angle, this is the side, so I'm going to start with x squared equals. There's that in there, yep. So I'm going to go x squared equals 4 squared plus 8 squared. It starts out looking like the Pythagorean theorem here. And then you subtract 2 times the 4 and 8, or whatever's here. So 2 times 4 times 8. And then cosine of the angle that's opposite of x, which is theta. Okay, now from here, we can almost finish it. I mean, you should be able to finish it from here, but I know a lot of you are going to get stuck in one spot. Okay, the only other thing here, I've got my theta, so that's good. I've got my d theta dt, so when I take the derivative, I've got that. And then I'm trying to find dx dt. What's the other thing that I need? X. Can I find x if I know theta is pi over 6? Yes, using the law of cosines. So go ahead and try to find x using, this law here. It's not that hard, I promise. Just plug pi over 6 in back here. Make sure your calculator's in radians. And then you just take the square root to get x. And I would store that in your calculator as x or something, because I don't think it comes out nice, does it? So what is it approximately? Did someone get it? That's what I would do. Store it in your calculator. Did we get an ugly decimal? Okay, so it's about this, but just store it in your calculator so it's accurate. You guys all got different answers? My gosh.
No, I got that answer.
What one? That one?
No, I didn't. Look at it.
I just wrote down what you said.
You did it. Okay, see, there you go. You're right.
Okay, how many people got the 4.957 thing? Okay, we're going to go with that.
Who got 3.72?
Okay, I'm going to go with the 4.957 and assume that that's right. Yeah. And then take the derivative of what's down at the law of cosines and start plugging your pieces in, okay? I'll come around and help you if you weren't there. Your answer at the end should be about 0.005 millimeters per second. Okay, so glancing at 22 here for the end of the class. It says that a particle moves along the curve, so we're given y equals 2 sine of pi x over 2. And that says as it passes through the point 1/3, 1, its x-coordinate increases at a rate of square root of 10, so it seems like dx dt is square root of 10. Is that seeming right to everybody? How fast is the distance from the particle to the origin changing at this instant? So let's say z is the distance from the particle to the origin. So we're trying to find dz dt, right? When x is 1/3 and y is 1. And then you're going to use Pythagorean theorem, because if you drew from the point on the curve to the origin, you could create like a right triangle with the x and the y. So you're going to set up x squared plus y squared equals z squared. And then plug this in for y. And then you take the derivative. Okay?